To start this video about trekking with an altimeter or an altimeter, the question has to be asked is, do you really need one when you go trekking? And the simple answer to that is no, you definitely don't. But in some situations they do make things much simpler. So I've brought two of them today with me. This is a Suunto Core 7, I don't know if you can see that hopefully. This is a barometric altimeter and it costs around £160 or what's that, $200. This is a Garmin Fenix 7 Solar. It's a GPS altimeter and this costs around £650, what's that, $820. So you can buy 4 of these for the price of 1 of these. And at the end of this video I'll do a test and I'll see which one's more accurate. Is it worth spending extra money on this Garmin when a Suunto would do? But you know, let's leave that to the end of the video and we'll do a quick test. So as I've said, you don't really need an altimeter, but you know, we're here today to talk about what they are and how they work and how to use them. So you know, when we're out trekking around the hills, so we may as well go over this subject. So for the last question, how to use them, later on in this video I'll demonstrate some things which people with different levels of navigation skills and experience may want to use an altimeter for. So we'll look at novice, intermediate and advanced altimeter techniques. But the first two questions, you know, what are they and how do they work? I'm going to skip over that really quickly, so pay attention. I suppose, what are they? If you want to describe what an altimeter is, the simplest possible way you could do it would be to say that it's a device which displays your height above sea level. So we now know what a GPS is, and the next question is, how do they work? Well, today I'm going to keep things as simple as I possibly can. You know, it's always easy to overcomplicate things, but you know, the idea of these videos is to simplify everything. So I'm only going to look at the main 2 types of altimeters that you and I would use when we're walking around the countryside, and that is a GPS altimeter, which is like this Garmin one, and a barometric altimeter like this Suunto. And I do appreciate that I do look a bit strange having 2 watches on different altimeters. Sometimes I can be found walking across the countryside with 15 or 20 totally different types of compasses dangling around my neck. I do get some very strange glances from passers-by. Anyway, let's start with the GPS. How does a GPS altimeter work? Well, I don't know where to start. In the 1970s in America, they started to develop a series of satellites that they would position around the Earth, and these will enable you and I to go trekking at the weekend, and obviously they can be used for other things. And this system I think was finished in 1995. Okay, there are other satellite systems. There's the GLONASS, that's the Russian one. There's the BeiDou, which is a Chinese system, and there's the Galileo, which is operated by the European Union. Now, there are some other ones which only cover a small section of the world, like India's got a satellite system, but it only covers some bits of Asia. Japan has also got a system which only covers some bits of Asia. Now, each of these satellites has an atomic clock on board, so it's really accurate. That's the best way to put it out. And they send out signals containing details of the time, and you know, the time when the signal was sent out, and also the location that it was sent from. Now, your GPS unit, or my watch, can receive these signals, and working out the difference between the time of the signals and the location that it was sent from, assuming that it can see 3 or 4 satellites, it can triangulate its position to anywhere virtually on the surface of the Earth. So that's how a GPS sort of knows where it is. That is a really basic run through of how a GPS altimeter works. But you know, there are lots of other videos where people go into great minute detail. I may do one day, but not today. So that's how a GPS altimeter works. The other main type of altimeter that normally you or I would use to go trekking is a barometric altimeter. So let's have a look at how they work. The theory is, if you go up, the air pressure reduces, it decreases. If you go down, the air pressure increases. And these changes in air pressure, it changes by a known amount, a set amount per meter. Now, your barometer, your altimeter barometer, it can calculate your height loss or your gain. As an example, let's say the air pressure at your location is a certain number of millibars and you walk uphill for some distance. The barometer will continually test the air pressure as you're walking up, and so it'll be able to calculate the height gain. You know, it's quite simple. Now obviously there is a problem with this. As a barometer is using air pressure to calculate a height, anything that affects the air pressure will also affect the accuracy of the reading. You know, this could be things like, is it daytime or nighttime? You know, the weather conditions, how much moisture is in the air. There are lots of things that can change the air pressure, even if you're just standing still. You know, but I'm trying to work out with how to put this politely. The most important thing that will affect the accuracy of your barometric altimeter is how you use it. If you use it correctly, it'll work. If you don't, it won't. Dead simple. So that was a really quick and basic rundown, a description between a GPS altimeter and a barometric altimeter. Now we know what they are and how they work. Let's talk about how you actually use an altimeter, or altimeter. We'll start with the GPS one. Most modern GPS watches, you can adjust the settings. You know, you can adjust them in virtually any way that you want. As an example, I can tell this Garmin what my height is now, and it will use that as a reference. You know, so if I go up 100 meters, it will simply add 100 meters to the height that I set, or if I go down, it will subtract 100 meters from that height. But to me, that's a bit pointless. You know, why would you spend much more money on something that you have to continually reset throughout the day? You know, this is a GPS altimeter, you know, so obviously, you know, I would suggest just leave it in automatic, and you know, but that's up to you. With a barometric altimeter, it's not so simple, but they are much cheaper, and that's why they're so popular. There are a lot more people wearing Suuntos than there are the Garmin Fenix. You know, they are much cheaper. But as I said before, lots of things can affect the barometric altimeter. So this is the most important thing. You need to reset them when you get to a known altitude, a known height. As an example, give me 30 seconds. I shall get sorry about this, I should have got myself organised. I've got a compass and I've got a map of this area. So let's have a look. Where am I at the moment? So I am now I'm on map SD. So I'm at SD 8773 6828. So that's my position to within 10 meters, right by this track wall junction. So it's near enough within 10 meters. Now my map shows me that at the moment, you know, I'm at 430 meters above sea level. So I need to input that 430 meters into my Suunto as a reference point. And now if I walk uphill, it will be able to calculate how much I've gone up and down, you know, how much the change is from 430 meters. Now, if my map didn't show the correct height, there are lots of other ways that you can tell what your height is, you know, just by the information on the map. It doesn't have to be a spot height or a trig point or anything like that. So if there isn't anything, I can just start walking until I come across something, you know, which is shown on the map. Now, with a barometric altimeter, the trick is to keep resetting the height on the unit every now and again throughout the day. You know, you don't have to do it that often. You know, if the weather stays the same, or you haven't, you know, if you're walking on a quite flat ground or over easy terrain, you don't need to set it that often. But if the weather's changing, or you've gone up sort of 200 or 300 meters, then, you know, every time you get to something with a known height, just have a quick look at your barometric altimeter, and if it's not correct, if it doesn't agree with what the map says, then just set a new reference point. Okay, so it's just good practice to look at things as you're going along. So before I leave here, I'll set my altimeter at 430 meters. So that's it. We now know what they are and how they work. So that's done. Now let's have a look at some possible uses for an altimeter. Let's go for a walk. So I'm getting cold standing here. So first of all let's look at possible novice, intermediate and advanced uses of an altimeter. A novice altimeter technique would be something like finding your way, finding your location when you're walking along a linear feature. I mean, this could be something like a river or a road or a track or a wall, something that you can walk along or parallel to. Now, at the moment, I'm on No Fell, and I'm at the junction of a major footpath called the Pennine Way, which is quite famous in England. People actually walk the entire length. I've never done it, but it looks good fun. So I'm at the junction of the Pennine Way and a wall. So I can identify exactly, literally to the meter where I am on the map. And on my map, it tells me that I'm at the 430 contour line. Now I want to walk up to the trig point, which is at, let's have a look, 593 meters. So that's a rise of, should have worked this out, 163 meters I need to rise. So I'll walk over 16 contour lines on my map. And the distance from here to the trig point is, bear with, there we go, 1100 meters. So 1,100 meters. So it's going to take me approximately 33 minutes from here to get to the top. I made a video, by the way, showing how to work out how long a route would take you. I'll put the description. I'll put the link in the description box. It's called Naismith's rule. Now, looking at the map, I can see that when I get to around the 480 meter mark, I'm going to start walking through an area with lots of shake holes, and I want to know when I'm getting near to those. And if it was at night time, it'd be even more serious. I would need to know. Shake holes, by the way, I've done a video on shake holes as well. I'll also put the link in the description box. If I'm on my own out here in the middle of nowhere, if I fall down one of those shake holes, nobody will ever be able to find me. They won't know which one I've gone down. And for me, it would be problematic. So I do need to know. So, today is a nice day. You can see for miles. But if I was walking in this area at night, as I have done on previous videos, once again, I'll put the description in the box. Or if it was foggy or any other type of reduced visibility, when my altimeter tells me I'm at 470, I will start paying more attention to the track. Altimeters are really good at this, if at a novice level. When you get to a certain height, if you know there's something not so good there, then start paying more attention. So I'm going to start walking up the track. In fact, no, I'm not. I'll turn the camera around so you can actually see what is directly up the track. I don't know if you can see that. Hopefully you can see them. Now, let's go around the back. Can you see those? Yeah, there they are, and they're literally there. You see those? Not good. So I shan't be. The track actually goes in that direction, but it goes directly through a herd of cows, and that herd of cows, there are lots of calves, and if you look at them, most of them are only a few weeks old, and I think their mothers may get a bit upset with me. So safety first. Once again, there is a system called boxing. The military use it all the time for finding something, but what I can do is I can use it to get round those cows and then get back onto the track. Basically, I know if I walk up in that direction for X amount of meters, when I get, say, 200, 400, whatever, all I need to do then is stop, turn at right angles up the hill for an amount of distance that will get me past the herd, and then I simply turn at right angles again and come back in for exactly the same amount, and that will get me back onto this track. So I better set off because I'm not walking through all those. So this is the 480 mark. Well, I'm now on the 480 contour. I don't know if you can see this one here. It's an enormous hole here. Oh dear. This is the actual track here. So I'm actually on the track. In the daytime like I am now, it's not a problem, I can see. At night time now, I would be scanning everywhere with my torch, walking very, very slowly. I don't know if, hopefully you can make this out. This enormous pothole. Literally, what's that? That's no more than 2 meters from the track. And once you start sliding down the bank, well, let's not even go, let's not think about it. So, the altimeter warned me, well, the map warned me, but the altimeter told me when I was actually approaching this area. So, yeah, I'm not going to go I'm not going to go anywhere closer than that. So even for a novice, using an altimeter in a situation like this, where you're following a track through potentially dangerous areas, as I said, you don't need an altimeter, but they do come in handy now and again. Right, let's go up to the summit. An intermediate use of an altimeter may be to help you to avoid any dangerous terrain when you're walking over open countryside. I went to the top and I'm going to go hopefully back to where I started from. At the moment I'm by this wall junction which you can see behind me, which is hopefully on your screen. As I said, I want to go back to where I started from, but I want to try and avoid these 2 lines of shake holes because, well, they scare the hell out of me. So I'm going to follow the wall down that basically goes due south from the trig point, and I'm going to go as far as the 560 contour line, and my my 2 altimeters, so I'll be twice as safe, my 2 altimeters will tell me when I get to the 560 line. From there I'm just literally going to turn left and I'm going to go due east until I go between this area of crags just below the shake hole lines and this area of limestone pavement. So when I get there, I'll just need to go down and follow the wall down until I get to the 560 and then turn left, and we'll have another chat when I get to that area. And this is it. This is the 560 contour line. Now, as you can see behind me, this is just wide open countryside. It's not. There are no features that will tell me I'm here, other than my my altimeter, which will tell me. Now, don't get me wrong, you don't, as I've said, you don't need an altimeter. This is an intermediate technique, so any intermediate navigators will know how to use pacing and timing, and it'd be so easy to walk a few hundred meters down this wall. But at night time, or when it's foggy or you're late and it's raining and the rain's coming straight into your face and the wind's blowing and you've had enough, rather than counting paces and doing your timing, it's just easy to look at a 560 contour line and watch. So all I need to do from here is I need to go basically east, which is that direction. Now, on the map, hopefully you can see this on your screen, I'm going to go east from here, and when I get to the 500 contour line, even if the weather was horrendous and I couldn't see anything or it was night time, once I get to if I'm going from here due east, then I will know that I'm past the crags on my left and the limestone pavement on my right hand side. I'm actually through it. So all I need to do then is to continue going due east. I'll hit the track, turn left, and then I'll go through 3 walls and go through 2 walls, and at the 3rd wall just turn right and my car is at the bottom of that wall. So as you can see, that's an intermediate navigator would be able to use other methods, but an altimeter does make it easy. Right, I'm going to carry on down and hopefully find my car. An advanced technique that can be made easier with an altimeter is relocation. relocation, any advanced navigator can always relocate themselves. That's just to find out exactly where they are on a map. So let's think about this. So I know that I'm somewhere in this area. I've been walking around this area all day. I've not been over here, I've not been here, so I'm definitely in this area somewhere. Now you can see behind me, that way's up, that way's down. So we'll use the slope aspect, you know, the direction of the slope. I'll take a bearing down the slope, and I've got a bearing of 138. So I'll put this onto the map, 138. I'll set the compass at 138. I'll drop this onto your screen so you can see what I'm doing. Let's have a look. In fact, I can see the only slope in this whole area that goes on a bearing of 138 is in this area here. So I must be somewhere there. In fact, if I put my compass on it, I know that I'm somewhere along this line, but I don't exactly know where. But my altimeter tells me that I'm at 545. So along that line there, I now know that I'm at the 545 mark along the 138 bearing, so I'm exactly there. So I didn't know where I was, and within a few seconds I've now located myself. It would have been quicker if I hadn't been explaining what I was doing. But you see, so even though an advanced navigator would always be able to relocate them, that, you know, you can, even at night, you can find out where you are. This just makes life so much quicker. You see what I mean? So it's an advanced technique, slope aspect, but this just enhances it. So, you know, now depending on the weather conditions, I can use that information that I've just got of, you know, finding out of exactly where I am. I can use that then to decide, or help me decide on which direction I'm going to go from here. You know, the altimeter doesn't make the decision for me. All it does is it gives me information that I can use to then make a decision. Okay, so I think I'll go on, let's have a look, 110 degrees. So I'm going to go on 110 degrees, and let's measure it. So from here, it's 17 millimeters from here. So it doesn't seem fast. So 17 millimeters is 425 meters. So it's just over 6 minutes from here back to the Pennine Way footpath. How simple was that? As I said right at the beginning of this video, you don't really need an altimeter, but they do sometimes make things simpler and quicker. I would add one caveat to that. Don't rely on them. You know, like all technology, they can give you false information now and again. And if you're walking around an area like this, which is full of potholes and shake holes, and, you know, so it's potentially dangerous, you really should treat an altimeter as an aid to map reading. It doesn't replace the need to be able to read a map and use a compass. It's the same as a GPS. You can use it as an aid to navigation, but it doesn't in any way replace your absolute need to be able to really, you know, use a map and a compass. It just speeds things up. Oh yes, I said, let me put this up here. I said that at the beginning that we would, I've not actually looked at these. I said that we would have a look and see which one of these was the most accurate, a GPS or a barometric altimeter. So let's take them off. Now, I've just been on my mobile phone, I've been onto the Ordnance Survey database, which lists all the trig points in the whole of Great Britain. I'll bring the camera into, oh, they're quite similar. I'll bring the camera in closer so you can actually see the trig point. As I said, I've just been on the Ordnance Survey database online on my mobile phone. What did we do before we had mobile phones? It just seems I don't know. Anyway, on the map, this particular trig point is shown as 593 meters. Remember, that's above sea level. Sea level in the UK is a line on the wall at Newlyn Harbour in Cornwall. Now, with trig points, if it's got a flush bracket, don't forget, the registered height is at the top of this small brass arrow. If it's never had a flush bracket, then the registered height is of the nearest piece of natural ground. But this one has got a flush bracket. This is OSBM, Ordnance Survey benchmark S5526. So you can look it up on Google yourself. But I've just done it for you. The registered height of that exact point there is 593 meters, 44 centimeters and 5 millimeters. People think these lumps of concrete are just plonked here. They are so precisely positioned, you cannot believe it. Anyway, let's have a look. Well, I've just took these off. Let's hold them there. So anything between 593 and 594, because remember it's 44 centimeters, so it's halfway. Wow. Look at this. I've got to show you this. They are both showing exactly the same height, 594 meters. How amazing is that? Now, because they're both showing the same height, the next question should be, is it worth paying 4 times as much for the Garmin than you do for the Suunto? As I said, you can get 4 of these for the price of one of these. Mind you, on the Garmin ones, you can put maps and all the rest of it. You can get a heart rate monitor. You can do lots of stuff with it, but I don't have any maps on this or heart rate monitors or anything. To me, it's just an altimeter. But anyway, there you go. So if you want to get one, it's up to you. But anyway, thanks for watching.